Hi, welcome to the webinar series. I'm Nav Mathur at Neo4j, and I'm the Senior Director of Solutions. Today I'm going to talk to you about what does MDM have to do with innovation. Well, these MDM and innovation couldn't be any different. But let me give you a clue. It's all about the data. As the Economist magazine puts it, data is the new oil. And so I'm going to talk to you about how these things are related and how Neo4j plays a pivotal role in this relationship. And let me kind of talk to you about the agenda a little bit. So we're going to first start off looking at the current landscape in most large enterprises. And meanwhile, you'll have a little poll in your screens, and you can answer those questions as you listen to this. I'll then be introducing a case study for University of Washington. Peter Visser has built a great application called the Knowledge Navigator, and we'll talk about that. Next, I will talk about connected data in retail and give you a retail case study as well. And then we will talk about your systems of analysis and systems of engagement. So analysis, which produces insights, and the engagement, which produces the action, the decisions, and how those things can be brought together in real time. And then we will go deep into the first case study and do a demo. And then talk a little bit about Neo4j itself, what are the key features, and then conclude from there. So let's talk about the current landscape in most organizations today. Most organizations have multiple customer data silos within the organization, and now they've started putting a lot of this customer data in the cloud as well with Salesforce and with Trello and so forth, ServiceNow, and other customer-related cloud products and SaaS products out there. And then if you go forward, if you look at other silos of data like supply chain, you may have a lot of supply chain data coming from partners through various interfaces. You would have employee data. Employee data sits on the cloud as well with things like Workday and ADP. And you have product data as well, and product data can be in the cloud as well. So all in all, we have quite a mess with data being within the enterprise in multiple silos, it being your enterprise data being in the cloud, being with partners. So how do we bring all of this together to produce some meaningful information, reports, insights, applications that service the users and your customers? So what businesses started doing was mastering the data so that you have an authoritative and trustworthy source of this data. So you had sort of customer MDM initiatives, and they brought data together from all these customer silos. And similarly, you had other MDM silos with product and supply chain and employee. But you have on the other side these applications and reporting needs that don't just need data from one silo, but need data across all of these silos. So they need connected data. So you have a gap here in terms of the data that you have in these silos, and then what the applications need and these reports needs. So most organizations went ahead and started building data warehouses where they could pool all of this information from these different silos together in one humongous location to start producing these connected reports. And when that was successful, I said, well, we could do more. We wanted to produce insights. We want to have some analytics on this data. We want to do some ad hoc querying and drill downs. And so you started having this notion of a data lake where you could build insights, and you started employing data scientists and so forth to build those insights using machine learning and so forth. Well, the problem with that is you're still wanting to build these innovative emerging applications like cross-sell recommendations, like 360-degree view of your customer, which takes information from various different customer silos and other sources to build the most real-time view of the customer, so that your support desk, your sales force, and so forth have the most relevant and latest information as to what's going on with the customer. What does the customer's configuration look like at any given time, so that you can do a better job in selling and supporting the customer. Similarly, with other applications around risk management and impact analysis that need real-time information. And then now you have a lot of these regulations coming forward. The process continues to change. There's continuous change in these regulations, and more regulations are coming on board for financial services, for privacy, for healthcare, and so forth. So how do we deal with that? Which all of these applications need real-time data, need connected data across silos, but what you have is batch process data and slow queries. So this is what I call as the innovation gap, and this is where Neo4j plays, is in closing this innovation gap, because Neo4j can really bring together this master data and connect the master data across these silos with the metadata or with the context for these different applications. And it can do the queries in real time, and can do a lot of connected data in the hundreds of parameters, and connect them in real time and produce the results that are desired. So Neo4j can really sort of be a key technology differentiator for you in connecting your data silos together and having the metadata attached to it to be able to get the right context and meaning to the application that is going after this data and presenting it in a connected fashion to the end user, to drive these cross-sells and recommendations and know your customer use cases. So let's look at a case study to sort of drive home that point. We actually are in use at University of Washington, where Peter Visser, who talks about this now, is going to outline the use cases that they have with Neo4j in his Knowledge Navigator product. Hi, Peter. Welcome. Thanks for taking the time to talk to us about how University of Washington is using Neo4j. I think you have an interesting use case here that I wanted to share with the audience. Maybe you can start us off by introducing yourself.
Okay. My name is Peter Visser. I am a solutions architect at the University of Washington. I'm in the enterprise data and analytics group, which is responsible for the data warehouse and also BI using SSRS and Tableau mostly.
Tell us a little bit about the business problem that you were trying to solve initially.
So we had three different business problems that we wanted to solve. Firstly, we were already using a metadata vendor out there that the application just was very complicated. And so only really two people could use that, our metadata managers, but none of the end users could use it. And so we had a new request for a new glossary. And that kind of gave us a moment to step back and say, is this how we want to continue this work? And the consensus was it's really not usable for the end users. The second one is that we are changing our HR system. And so we're going from a 30-year-old mainframe system to a new cloud-based system called Workday. And so we needed to figure out how to move our members, how to help them migrate from the mainframe system to the new system. The mainframe data currently gets stored in the enterprise data warehouse. So post the implementation of the new system, they will need to go look at new databases. And so how do we use metadata to essentially do change management? And then the third use case was how do we help people that are still in development of a project to document their metadata as part of that project's methodology. So, for example, we might have lineage that we want to capture that then gets sent to our ETL team to get implemented. So how do we help them even before it's in production? How can we capture all that? So those are the three use cases that we try to solve.
I think a lot of people here may not have a very good idea of the scale and size of the University of Washington and how comparable is it to a large enterprise. So maybe you can talk a little bit about the size and scale so we can get a sense of the complexity of the environment there.
Well, the University of Washington is almost like a little city. We have about 50,000 students, but we also have about 30,000 people who work here. We have over 500 people in the IT department. So we have in just the data warehouse, we have 36 databases. We have about 6 terabytes of data every day that we move. We have 6 major subject areas, so anything from finance to HR to academics to research. We also have 6 hospitals, and so we're one of the largest public universities in the country, and we also have one of the largest amount of Tableau users, for example, or report users around. So I would say we're kind of in line with a really big enterprise.
So what made you decide on Neo4j? Did you evaluate other products as well before you came to the conclusion of using Neo4j and as the most appropriate solution for this system?
Yeah. So when I started working here, they already had a metadata solution. So they had a solution that was in SharePoint, and then they moved to a cloud vendor for metadata. But again, it really didn't work very well for anybody except for the metadata manager. Nobody could use it. And so when we started looking at how do we enhance it, we really took a step back and said, how would we do this, from scratch? So we looked at a bunch of vendors out there that could solve the problem, but none of them could really customize it the way we wanted customized. And so I started working really on a proof of concept, initially doing it in a relational database, and quickly ran into problems really because of the relational nature of metadata. Really, when you talk about metadata, everything is related. So a table is related to a business term, is related to a report. Everything's related. And when you do that in a relational database, it just quickly becomes a nightmare. Same with that we wanted a schemaless database. And so we were doing it in SQL Server and had to create basically a table for every type. And when that didn't work, we tried to create a generic data structure, which works, except when you start wanting to create relationships between those, and all of a sudden you have to create grandparent relationships and things like that. So our initial proof of concept essentially in SQL Server didn't work at all. We just could not get to the relational model the way we wanted to. So we did a proof of concept with Neo4j. I actually saw a presentation by Notre Dame at a national conference on how they were using it. And because of the relational nature, of Neo4j, it was actually a pretty easy data model to implement. We essentially just worked with Notre Dame on creating our first data model on a whiteboard, brought that into Neo4j, imported data from Excel, and had essentially a technical metadata repository and a business metadata repository in a week or so. And then we put a search on top of that, and essentially that became a version 1 of our Knowledge Navigator. And it worked pretty well. And then from then on, once we proved that we could use a graph database, we started enhancing the product.
Tell us a little bit about how. Hi, Peter. Great. So now you heard Peter explain how graphs are the right technology for metadata management and building this Knowledge Navigator product, which gives them, business glossary, technical glossary, and other use cases like impact analysis. We'll go deeper into this case study a little bit later, but first let me talk to you about graphs and MDM in retail. And we talked a little bit about these innovative applications like recommendations. So why don't we sort of double click on that and talk about a very common application, which is basically a mobile online store. And at the surface, it looks pretty simple. You've got basically your product, you've got some description, you've got a price, and you've got a place where you can put your shipping address and to search and so forth, and you can purchase the product. But if you look at it a little bit deeper, you've got a lot of personalization going on, so that the things that are being put out as products is related to what you like. You've got a lot of promotions going on. You've got recommendations in terms of what you like, what other people like you have liked, and other rules-based recommendations like that. You have product data. You have your routing and delivery information. So the whole logistics aspects of that comes in. You have your geo data, and then you have your inventory, which again feeds into your supply chain systems. And then you have your payment options, and you have your social data. So if you look at it, this is a huge web of connected data that is coming together to help you buy a product, which is a pretty simple concept, in itself. But the complexity of the application and the fact that all of this needs to be as real time as possible, and that's where the differentiator is in today's e-commerce world, makes it very difficult. So, just getting into it a little bit more, you have your, real-time inventory, which is supply chain data. You have recommendations, which is both customer data and product data coming together. And if you sort of look at it holistically, you have all of these data sources that need to be brought together to be able to produce this type of an application. And so what most organizations have done is sort of opt for building these recommendations offline using their data scientists and systems of analysis and insight to build these recommendations offline, and then move it into more online data stores that power these websites. So what you have is really good analytics, but it's not real time, and so that is a problem in a lot of retail e-commerce sites, and that is why Neo4j is being used by 7 of the top 10 retailers today to power the recommendation engines for their online commerce sites. So even though a lot of retailers are closing shop in terms of the physical presence, a lot of them are actually spending money on Neo4j to build their e-commerce sites and beef up their recommendations so that more relevant products are displayed to the customer and so forth. And that is really the power of the graph coming into play there. So let's simplify this a little bit more to explain how the graph works. So you have, let's say, a customer with a name, address, and so forth. And then you have sort of the product, which again has some attributes attached to it. And then thirdly, you might have another silo, which is sort of your store or your supply chain side of things with other attributes. So if you really think about it, you basically have a customer trying to buy a product from a store, and that is the context of that information. And the graph really links these pieces of data together with that context to power all of these different type of applications that require real-time connected data. So let's now talk about Adidas. Adidas is a really good example of one of our retail customers that is using Neo4j to connect multiple data silos together. And the context here is really they were essentially launching a campaign with key athletes, Paul Pogba and Lionel Messi, and they're paying them boatloads of money to run this campaign with them in the millions of dollars, and so they want to make sure they maximize the return on their investment. Now the investment is on merchandise. The investment is on advertisements. The investment is on storefronts, banners, and this is spread across multiple countries all across the globe. So how do they understand and come to grips with all of these aspects of not only digital commerce, but the on-site store commerce, and bring all of this together to understand the value that they are getting out of this relationship with Messi and Pogba. And so this is where Neo4j came in, bringing all these multiple disparate data sources together to understand the value that they are putting together with these athletes and capturing that. So it is powering Adidas.com. It's powering the CRM systems, wholesale systems, retail systems, and also the systems of insight. Their big data. So it's a comprehensive 360-degree view of the customer and what they're purchasing around this campaign. So it's again a very excellent way of using the graph to pull all of this information together in real time for this context. So just to give you a sense of how you would use Neo4j in a master data management situation, you would do it more as a do-it-yourself play. The MDM world today is fragmented with multiple players, and each have their niche. So you have a lot of MDM players that focus on product MDM. You have a lot of MDM players who focus on customer MDM. And typically that's what I've seen with most large enterprises. They have multiple MDM products in-house. And what Neo4j can do is you can really enhance the value of this investment that you already have made and bring these disparate MDM products together, connect these pieces together with Neo4j, and with providing the right metadata, the right context for that connection. And also, if you have areas that have not really been mastered, like for example, supply chain has not really been mastered today, you can do it yourself sort of way of connecting those disparate silos of supply chain together with Neo4j and connect it then up to product and customer, for example, to power these applications. Also, if you look at where MDM players are moving, a lot of the new entrants in this space are actually using graph to power their MDM products. A good example of that is Pitney Bowes, and there are several others out there who are also using graphs. So graph technology is definitely something is the future of MDM and metadata management. So let's talk a little bit about the loop between insight to action. So what I see is in most organizations today, if they're building insights or predictions with the help of their data scientists, they're using technologies like Hadoop, Spark. They have a data lake on which they build these insights. But then to power these applications, you need to walk these insights over to another data store that then powers these applications to provide this real-time interaction, because big data is not the right technology to power real-time applications. So there is a big gap in terms of the insights that you produce and the action that you want in real time. And so I look at this as like a timeless pattern where you have batch processing, and then you have your real-time processing. And if you just look at that retail example again, you may have been shopping for furniture in the past, and when you go online to shop again, you will get a lot of recommendations for furniture because that has been your past behavior. That is the insight that they have learned over time from your interactions. But now you want to search and buy a television. So alongside the television, you'll be getting a lot of furniture promotions and so forth, and that's just the wrong thing to do at that moment. So it's again not real time. So again, there's a gap there in terms of the batch process data and the real time data that you need. So how do we bring these two things together? Your systems of analysis and your systems of insight on one side, and your systems of engagement, your transactional applications on the other side. Well, this is where Neo4j really comes in. It can bridge this gap very, very well, and we can produce the insights as well as have the ability to query this data store in real time across multiple connected data items to produce the action, to produce the recommendations, in real time. Here's I kind of had a laugh reading this article in InfoWorld recently. This is about the passenger United Airlines that was literally dragged off the flight and suffered a lot of trauma. So there's a headline in InfoWorld that says data science could keep United out of more trouble. And the interesting thing is you could have had all the powerful systems to give you the insight that this crew needed to be on this flight because this crew was needed in another location, and they could have had this insight available to them before even the passengers boarded, so they didn't have to kick the passengers out. But the problem was there was really nobody there or no system there that could take that decision for them, even if they had these insights. And much less, even common sense didn't prevail in this situation. So the message really is that insights are great, but you really need action to be able to translate those insights to something that is meaningful for your end user, for your customer. So how do we put this together in terms of architecture? If you look at your transaction, let's say you have your purchases coming in. They're going into a transactional database. You have your merchant data, you have other third-party data, you have credit score data, also coming in to a data lake, and you have your data science team sort of building your insights, building insight not only on sort of your customers, but also possibly helping prevent fraud by looking at all of this data. So you may have you may build these patterns that your data science team proposes, and then you can basically load a subset of that data into Neo4j relevant to those patterns. So just those parameters. So you're not loading the entire data set, but you're loading a subset of the data set relevant to the pattern that you want to action. And then you can visualize this pattern with Neo4j because now you have it in a graph. It's very easy to visualize graphs. And you can then remove false positives. You can look at other parameters that are related, but not part of the pattern now, but it's very apparent when you visually look at the data. So in other words, your data science team can actually visually look at this data now and fine-tune this pattern, find all instances of this pattern, and make it available in Neo4j. And then now when you have your transactions coming in, you can stream part of the parameters directly into Neo4j to do the pattern matching. Once your pattern is matched, you can actually respond by kicking off a process, by stopping the transaction, by notifying somebody, or to visualize that transaction to make sure that it's not fraudulent, and prevent additional liability to your company. So in other words, this is what I call a sense and respond architecture. where the outer loop is really building the insights and the inner loop is executing the actions and bringing this together with Neo4j. So now let's go back to our first video with Peter, and let's listen to it in more detail. He talks about impact analysis and data lineage and how he has used that in the university to really cut costs and with this move to Workday that they have been planned for system modernization. How you evolved this solution over time and what sort of features that you've added.
So if you look at our three use cases, for example, the first use case is really just to create a metadata repository of business terms and technical terms. Now that's relatively easy with a relational database. You essentially just create a database to a table to a column. And so that part was easy, but then we actually, when you start adding our other business cases in there, like how do you show someone the change from this database to that database? So how do you say this table that you used to look at it in the old database is now related to this other table, or this table has now been discontinued? Those changes starts getting much more complicated in a relational database. Then the other use case was basically how do we show the impact on those tables? So one column becomes the source for another column, or one table impacts another column. Every single one of those things become relationships and become a foreign key relationship that is very, very difficult to maintain. So it just kept adding on the depth of our data structure. And then lastly is how do we actually use those tables within our reports? If a report contains multiple fields, and those fields then contain business terms, how do those relate to each other? So it really, from a relational database standpoint, became a nightmare. Our initial proof of concept was to create a repository of business terms and technical terms. Your business terms were what we put in a glossary today, and then technical terms were basically databases to tables to columns. Then we put a search engine on top of that, actually still using Neo4j and actually just doing a context search within Neo4j. And that was our proof of concept. Can we essentially connect business terms up to technical terms? When we could show that visually, that's when we kind of had the aha moment, where it moved from being just a simple repository to people being able to see the context of the metadata. And so on a business term, you might say that this business term has related terms. But if the one that it's related to also has related terms, all of a sudden you start seeing it within context. And when that relates to a table or a column, the users start feeling like they can actually navigate, which is where the word knowledge navigator come from. They can navigate the metadata because they can jump between business metadata and technical metadata seamlessly. So in addition to that, then we added a layer on top, which is a conceptual layer. So you would also call it a semantic layer. You put that on top of your business term. So that basically, you start on your conceptual layer, you get some context, you get to your business terms, and then you get to your implementation layer, which is your tables and columns. And then you can say, well, this table is impacted by another table, or a report is impacted by this table. So if you change this table, then that report will be impacted. And then you can take it even a level lower, where you can say, well, this column within this table is a source for another column. And if you start doing that, now you get lineage. So we started implementing, we started taking a look at all our reports, our SSRS reports, and we looked at what are all the tables that make up this SSRS report, and then what are all the columns within those tables. And then we can step it back all the way to the enterprise data warehouse and all the way to the source system. And so we can do complete impact analysis now of all our tables within the data warehouse and their reports. And then we can do lineage. And then we've also been working out how can, so one column plus another column makes a third column. So we can do calculations within that. And we can actually then bring that up visually to show people the lineage within our whole enterprise data warehouse. One of the interesting things about that, though, is within enterprise data warehouse, you usually pull data into a staging server and integration server. Now, people don't need to know that. Most of our end users don't need to know what goes on within the data warehouse. They just want to know what happened before it, and then what happens when it is out in a presentation layer. Now, we can actually stitch those together within Neo4j and then show the path only from the beginning and the end, and actually skip all the middle, the internal jumps, but show them the lineage of all the kind of the public lineage. And then for internal developers, we can show the internal lineage as well. Something that would be completely impossible to do in a relational database.
So tell us a little bit about how the business is starting to value this solution, and how your team has grown over time to support this.
So the HR replacement project is our biggest project probably ever. It's a multi-billion-dollar project, and so the project, the Knowledge Navigator, is the tool that we use to help change management for that. I mean, so this project impacts all 50,000 people who work here, and there are over 100 people who use that data every single day. So we are the single tool that are used for people to know what changes are coming, which reports are impacted, how they're impacted, which tables are impacted. So just from that perspective, it's huge. And also, we have two other replacement projects coming as well. We have the finance replacement project, and then we're replacing our student system right after that. And so we are able to use this metadata to actually show impact on those systems beforehand. And we can also show who the users are that we actually need to communicate to know about system changes coming. So that's been really big for us. In addition to that, I started this project really by myself about a year or so ago, and this has been a lot of buy-in. Our CIO has been absolutely a champion for this product, and we have now got a whole team around this product. We have a product manager, a QA person, a developer, a metadata manager, just a whole team built around this product to support the vision going forward. I think one of the strengths that we have is that we have just a large scale university that is full of metadata, and there has never been a single repository for all this metadata. So especially from a lineage perspective, that has been probably the one thing that everybody gets very excited about, is how can we finally, especially because we have some old mainframe systems and they get pulled into all these middleware systems, how can we actually trace that all the way through? One other thing I would just mention is one of our strategies now is to create really an integration platform. So essentially a web service platform in the middle that feeds into the data warehouse, but that actually is also the place where all our cloud applications go to. So to be able to document that integration platform, that's on probably one of our biggest projects that we're on right now, and that would show tremendous value to the university.
I think you found a very interesting use case here of really trying to do the impact analysis as you're trying to modernize the systems at the University of Washington, and using this product to help with that process. Can you tell us a little bit about what is in the future for this product? What sorts of additional features you want to add going forward? What's on the roadmap?
Yeah, one of the things that we have is we have a couple of different portals for BI specifically, and so we've been working on really integrating metadata into those portals and also into software really that's on people's machines. So, for example, being able to highlight something in Microsoft Word and then getting the definition for it right there. So, in order to do that, we need to put on APIs on top of Neo4j to do that. So we've really been working with Neo4j and Elasticsearch really to kind of create public interfaces, not only to get data out, but then also for data in. So how do we get systems out there to give us metadata? So today we're really pulling metadata from all these systems, but in the future, especially from a lineage perspective, we want them to give us lineage of the systems they know about. So for example, they may know from A to B the lineage, and we might know, the next people might know from D to E. So we can't expect a single system to know them all, but if they each give us their piece, then Neo4j will help us to map together A to B, B to C, D to E, and so forth, and to give us that complete picture. We cannot pull that from every single place, and so ideally we would now create an API where they can give us that. I think most of the work we're doing today is actually to work on loading and validating the data before it comes in to the metadata repository. So we are able to go today to ER Studio, for example. We are able to go to Swagger. We are able to go to SSRS, SSAS, all these different places. But each one of those really need a connector, need some kind of tool to get that information out and convert it into the graph data. So that's most of the work we're doing. Once it's in Neo4j, that's easy. That's the stitching. It can do that, pretty easily. But it's the upfront work trying to get all that information that I'm really working on. So today I'm working on putting in cubes, for example, as well, and Tableau. In addition to that, we are just adding more and more types of metadata. So we're looking at diagrams, for example. We're looking at business process models, those kind of things. I think the challenge that we run into is trying to keep it simple from an end user perspective. Like I said before, we've had other metadata applications before, and they actually become so difficult to use that the end users can't use them anymore. Only the metadata managers can use it. So we do not want to become the thing that we actually try to avoid in the first place. We want to try and keep it simple, yet put enough information in there that we can give people the complete picture of where the metadata is and what it does. For example, just yesterday I was working on a problem that was talking about how a data was coming through our source system into the data warehouse, into a data store that then gets used by some reports. But that same data comes from a source system into a web service and then gets used by applications. Now, I've been working on pulling in all the web service metadata. And so all of a sudden I can do a query now that can actually see how my data from my web service is actually connected to the same data in my data warehouse. And those two actually connect to a business term, which will then in turn connect to a report. So my end user, for example, came back and said, well, I've just been told I should no longer use this table. I should use a web service instead. How do I make these changes? Well, by having really the lineage all the way from the source system to both these tables, I can actually do a query and easily help that problem. Another feature that has been kind of interesting for us is from a governance perspective. Today we give people permissions to certain tables, for example, and we can say, well, so this table, you can see the table, but you can't see the social security number on that table, or so we have column-based security. Now, if you want to run a report based on that table, I can actually go back and look at that report, analyze all the reports, all the tables underneath that report, and then I can connect it all the way up to the data custodian that's responsible for that table. And now I can create a complete data governance security workflow for approval for a specific report. Where before it was really a shot in the dark. You said, well, I wanted this report. I want access to this report. I'm just going to guess that I should ask ask the academics data custodian, for example. Well, now I can know exactly who the custodian is for each of those tables, each of those columns, by doing a query within my Neo4j database.
Peter, thank you for an excellent conversation. This is a very innovative use of Neo4j to do master data, metadata management, and a data lineage as well. Thank you so much for your time. So now that you've heard Peter explaining the Knowledge Navigator, I thought, why don't we just take a quick run through it live. So this is the live environment that you're seeing now at UW. So Knowledge Navigator is basically the data governance platform, and here you're able to search for different terms. You can also navigate through this tree structure here, and then you also have subject areas that, as Peter alluded to earlier, so you can actually click on these subject areas and go deeper into by subject area as well. So just to kind of give you a demonstration, let's first look at business terms and how they have modeled that. So you have your student and academic terms, and let's go into student data business terms here, and let's look at ABB major. ABB major, as you can see, there's a definition, there's related objects on the left side, you have a glossary, you have your notes and so forth, you have the source of this data, and then you have your last update time and so forth. What's really interesting is the map that it throws up on this right side. This is a graph of basically saying that your ABB major is a selected term, and this term is related to activity-based budgeting and related to a major, and then major in turn is related to these other terms and so forth. So you can basically produce a graph of these related terms, and this is very helpful to understand really the business context of this term. And not only that, I think if you have your data integration problems or data integration that you need to do, where you're bringing data either from internal sources or external sources, frequently you're trying to really map this data into an existing field or column, and it's a challenge because a lot of the metadata on that column is either dated or even if you can find it, you're not sure whether it really maps completely to that column or the other columns that also are related to this, and maybe you need to transform this data, you need to split this data or combine this data with something else to really map it exactly to the column that you have in mind. So all of that, those type of issues are completely resolved by having this type of related terms graph. And so let's go back here and let's look at these student data business terms once again. And I also noticed that there is this student data navigation map. So let's take a look at this here. So as you can see here, this is a map of student and all the entities it's related to. So it's kind of like an ontology. So you've got an ontology on student, and then you have your business terms related to student and academic. So you can start seeing how they have built this data model, which you saw earlier in the talk that Peter gave. And now going back here, let's look at the enterprise data warehouse and look at some of the technical metadata. So here we're going to go into EW presentation and then look at dim date, for example. So here you can see dim date is, as per the legend here, it's present in two different BI reports. And you've got sort of, again, the definition, and you've got also the access rights, right? So the other interesting thing they have done is they have got entitlements on these data built right into this system. So not only do they have their identity graph here, but they also have their graph on students and academics and courses. So it's like basically all of these different silos are connected together to form this graph. Um, and it's really interesting because now you can start to restrict access to certain pieces of data based on the roles and access rights. And also when you're building these reports, you can understand which terms have what kind of access. So when you're planning for that, when you're reporting or other needs, you take that into account. So let's go back here and look at one other thing. So let's look at Enterprise Data Warehouse again, and then this time let's look at this ODS called HEPS. And let's go down here and look at the person entity right there. And as you can see, again, this is multi-levels of depth, and you can see all the tables that are related to person, and the business terms associated with that, and all of that. You can change the level of depth here and refresh it, and then you just get the tables related to the person entity, and you can keep modifying that to get different levels of depth, and that's again another feature of Neo4j, that it doesn't matter really how many levels of depth you go in a graph. The queries are really super fast and can build this graph in real time for you. Let's look at outbound dependencies. So as you can see, the person entity is available in all of these BI reports. So again, this is a really easy and straightforward way for you to look at how these pieces of data are related from business perspective, technical perspective. What reports do they fall into? So if you have changes in reports and so forth, it's very easy to do an impact analysis. Also, as Peter pointed out, when they did system modernizations with Workday, and now they're doing with others, it's really straightforward to understand, what columns, what tables, what terms are moving from the old system to new. What is the mapping? What does the lineage look like between the two systems? And also another side benefit is that you can now understand the technical debt from a data perspective, so that if you have fields or terms that are actually not being mapped to the new system, then you need to understand that to be able to decide, hey, this is just legacy information, we don't need that anymore, or we're really missing something. And either way, you have to do something about it to either clean it up or remap it appropriately. So there's a lot of benefit to having this type of a data governance mechanism and platform overall. With that, let me move back into the presentation and talk about Neo4j and conclude. Just give me a second here. All right, so let's talk about Neo4j and the key features of Neo4j. So asset transactions. So Neo4j is really asset compliant, and what that means is we don't lose any data under any circumstances. We are completely transactional in nature, and so we're absolutely, even in a clustered environment, guaranteeing that your data will never be lost. In addition to that, from an agility standpoint, we are a native property graph model. What that means is that we store the data exactly as you represent it on a whiteboard. So it's stored in the file system of Neo4j as a graph. So we've got the nodes linked to their subsequent nodes within the data structure itself, and that's really the difference in our technology. That what makes us extremely powerful, fast, and scalable. And we can also modify the schema as you go. So we subscribe to sort of the agile way of development because the schema modifications are easy on the fly. From a performance scalability standpoint, there's a term called index-free adjacency. What that means is that we do pointer chasing to find sort of the related nodes, and pointer chasing is basically CPU math. So it's done by the CPU. We're not actually looking at indexes and resolving those indexes and then going to that memory location. We're actually looking at just the each node, and then each node has pointed to the next node, and we're just sort of doing that memory arithmetic in the CPU to locate the next items in that related to that particular node. So it's very easy traversal, and that's what makes us really fast, and we can scale to sort of planetary scale with billions of nodes, billions of relationships, and hundreds of millions of operations per day. So some of the largest financial services sites, retailers, are using Neo4j today. Then from a developer productivity standpoint, we have Cypher as our query language, which is very easy to learn, and it's really ASCII art. And there are a lot of tutorials online on the Neo4j YouTube channel that you can go and learn this. It's really easy. We also have a lot of procedures that we have built over time on analytics, on simple functions that you do with data on a day-to-day basis. So you don't have to rewrite those things. They're already pre-built Cypher procedures that you can leverage in your application. And we offer a lot of support and training around all of this, and a very, very robust and very active developer community around the world that is contributing to all of these efforts. And then lastly, and not the least, hardware efficiency. So we are extremely make good use of CPU resources and memory resources. Our computing ability for the same quantum of computing is much more with our technology compared to some of our competitors. So as a result, we end up using a lot less of the hardware and memory that our competitors use because we are that much more efficient from that perspective, and that frees up resources for you. It also, from a licensing perspective, is cheaper when you look at the holistic picture. So in conclusion, once you have this master data, that's not the end of the road. That's really where the fun starts, and you can do so much more by connecting these master data silos together with the metadata, with the right context to produce these innovative applications, as you saw today in this talk. And you can, with these sort of innovative and disruptive application, you can create true business value, as a lot of companies, in Silicon Valley and in the West Coast, like Google and LinkedIn and Amazon have done. They have done this with the power of graphs themselves. And in fact, LinkedIn is using us when they launched in China as well. So there's a lot of validation to this technology, and we can see a lot of companies that is using this type of graph technology leapfrogging the competition by doing things more in real time and doing things more at the moment, which is what customers want. And so moving from managing data to finding strategic uses of this data. I think this is really, really important. And going forward, as this whole area of data-driven enterprise and digital is really going to take root, the roles are going to be changing. And I think people who can find ways to use this data more strategically for these innovative applications and work with the enterprise architects and business leaders. So today, if you're a data manager, data scientist, I think you should look into really becoming a data strategist going forward. I think this is really something that's coming, and you can already see that on LinkedIn. If I did a quick search, I found 60, 70 data strategists already out there, but thousands and thousands of data managers and data scientists. So I think this is an area from a career standpoint where not only you are going to benefit, but your company, your enterprise is going to benefit from this as well. So traditionally, you look at the data pipeline from sort of your data sources, your ETL, then how do you sort of integrate that data into a staging area, and then so on and so forth. But here you really need to look at it sort of from a flip perspective, where you can look at what are the metrics, what are the applications, what are the KPIs that you want to drive within your organization, what do your business leaders want, and then what is the data behind it, and how can I harness that data, connect it together with the right metadata with Neo4j, and provide those metrics, provide those KPIs to your management, or build those strategic applications that is going to leapfrog the competition. So to put it simply, a data strategist connects the data, derives insights, and then turns these insights into action. And that's really what is driving innovation today. So IT departments really need better metadata to guide major system upgrades, as you saw with the example of University of Washington, and like a lot of modernization and moving applications to SaaS in most enterprises today. And so they really do need this type of a data governance mechanism to alleviate the pressure on cost increases and time overruns for these projects, so that you can manage that impact analysis much better. Also, if you look at BI and analytics teams, they need better lineage and consumption information in order to trust what they fish out of these data lakes. And then risk and compliance officers need visibility and proof points that they'll be able to satisfy these new privacy and retention rules. A lot of regulation is coming up both in Europe and here in the US, and in order to satisfy these regulations, that data lineage, or reverse data lineage as it's called, when walking back the data to its source, is really, really important. And these type of systems with graphs are the right way to handle it. Also, if you look at solution architects and application developers, they need connected master data with the context, with the right metadata to build their next breakthrough application and starve off the competition. So all of these are reasons where graph technology and connecting your master data together with the right context has a huge bearing on what you build for the future. So in terms of next steps, what I'd like to offer you today is a brown bag graph talk with your team. Please go ahead and register at that link provided, and we can come in and help you with understanding graphs and how graphs could help you in your organization. The other thing I would like to offer is, for the first 5 people who email me, I can spend an hour with you directly to validate your solution or architecture or proof of concept. Or if you are looking to validate your data model, or actually looking to present a business case to your management on a particular initiative you've planned using graphs, we can help you with that. So please do email me at nav@neo4j.com. And thank you so much for listening and attending this webinar. Thank you.